Assalamualaikum and hi everyone. In this video, I will talk about subtopic 2.2 orbit, cycles and the alternating groups. What is permutation? Permutation sigma here of set A determines a natural partition of A into cells with property that element A and B in A are in the same cell. That means we have a cell here, we have a cell, and then we have element A and B in A. We have A and B, and this is a sigma. If and only if B is sigma power n of A. That means we have sigma here and then B which is equal to, we start with A is maps to sigma of A, and then B is mapped into sigma of B. And for A and B in A, we let A is related to B if and only if B is equal to sigma to the power of n of A for some n in integer. And this permutation follows these three equivalent relations. The first one is reflexive when we have A is related to A. The second one is symmetric. When we have A is related to B, then B is related to A. And the last one is transitivity. When we have A is related to B and B is related to C, so A is related to C. Now we'll proceed to definition 1, which is orbit. Orbit is actually a subset of the permutations that cycle through one another, or we call this as the orbits. Orbits, from this definition, we have sigma be a permutation of a set A, and then equivalent classes in this set determined by the equivalent relation in one. Okay, in this equation, and we call it as a orbits of sigma. Now look at example 1. Number 2. Find the orbit of the permutation sigma. We have sigma here, sigma which is the permutation with 8 element in symmetric group of degree 8. Now we want to find the orbit of this permutation. We want to solve number 2, and then this one, orbits of sigma, right? Orbit of sigma. We start with 1. Okay, our orbit is right in this bracket because it is in a class, all right? In a class of permutation. Open this bracket, 1 to 3, and then we go to 3. 3 is mapped to 6, and next 6 is mapped to 1. So we have 1 to 3, and then 3 to 6, 6 compared to 1. Okay, next 1 to 3, and then we start with 2. 2 is mapped to 8, and then 8 is maps to 2. So 2 to 8, 8 go back to 2. What is next? 4. We have 1, 3, 6, 2x, and we have 1. We have 4. 4 to 7, 7 to 5, and 5 go back to 4. 4 to 7, 7 to 5, and then 5 is go back to 4. So here are the orbits of sigma: 1, 3, 6, 2, 8, and also 4, 7, 5. Definition 2 is about the cycle. A cycle, in a simpler word, it is a permutation in a metric form. Can be written in much simpler notations. What about the length of a cycle? It is the number of elements in its largest orbits. Look at example 2. Number 1. Working within a symmetric group of degree 5, we see that 1, 3, 5, 4 is similar or is equal to this metric notation of this permutation. 1 is goes to 3, 3 to 5, and then 5 to 4, 4 to 1. We have 1 to 3, 3 to 5, and then 5 to 4. From this cycle, okay, we can see that we can find 1, 3, 5, 4 is also equivalent or is equal to 3, 5, 4, 1 equal to 5, 4, 1, 3, and also equal to 4, 1, 3, 5. Right, since we have cycle, a cycle of 1, then 2, 3, 3 to 5, 5 to 4, 1 to 3, 3 is mapped to 6, 3 is mapped to 5, 5 is mapped to 4, and 4 goes to 1 back. Either we want to start 4, 4 is mapped to 1, 1 to 3, 3 to 6, or sorry, this is not 6, this is 5. 3 maps to 5, and then 5 to 4, 4 to 1. For example number 2, working within a symmetric group of degree A, we see that alpha is this permutation and beta is the permutation, which is element of A. What we can have here for alpha. Alpha is actually in cycle notation, we can write it in 1 to 6, 6 maps to 1. So 1 to 6, and the 1 we have 2 to 4, 4 is mapped to 7, 7 is mapped to 5, 5 to 2. So we have 2, 4, 7, and 5. 3, what about 3? Okay, we have 1, 6, 2, 4, 7, 5, 3. 3 is mapped to 8, and then 8 go back to 3. Okay, this in cycle notation. We write alpha in this form, and after that for beta, 1 is mapped to 6, 6 to 3, 3 to 1. So we have 1, 6, 3, and then what about 2? 2 to 5, 5 to 8, 8 to 7, 7 to 4, 4 to 2. So this one, we have 2 to 5, 5 to 8, 8 to 7, and 7 to 4. what if I want to find alpha multiply with beta by calculating this using the cycle notation, not this metric notation. So we write all of the cycle alpha, which is we have 1, 6, 2, 4, 7, 5, and then 3, 8, multiply with beta, which is 1, 6, 3, and also 2, 5, 8, 7, 4. So now we want to multiply from right to the left. 1 is not here, so that means 1 is goes to 1, 1 to 6, 6 also not here, 6 is not here, 6 goes to 1. That means we have 1, 2. In total, 1 is mapped to 1. What about 2? 2 maps to 5. 5 is not here. That means 5 is mapped to 5. Also, it's not here. 5 to 2. And then here, 2 to 2. Go back to 3. What about 3? 3 is not here. 3 to 1. 1 to 1. 1 is mapped to 1. And 1 to 6. 3 to 6. So continue. 6. 6 is not here. That means 6 mapped to 6. 6 to 3. 6 to 3. 3 to 8. 8 to 8. And then 8 to 8. That means 3, 6, 8. Go back to 8. 8 to 7. 7 is not here. 7 is not here. 7 to 5. 5 is not here. That means it is goes to 5. What about 4? 4 to 2 is not here. 2 to 4. So 4. And the last one, 7. 7 to 4. 7 is not here. 7 to 5. Sorry, what is 7? 7 to 4. 4 to 4. 4 to 4. 4 to 7. I mean, go back to 7. So for alpha times beta, we have here, this is identity, and we have cycle of 3, 6, 8, and 5.